What's up, everybody? This is Mr. Maestas here with number 2 of the antiderivative slash integral. What was that? Integral video. So I've got some more examples here for you using these rules that we were just talking about for integration. So this is integration rules. So I'll write it up here. Integration rules. Follow the rules. This is 3-6 video B. So let's take a look at number 8 here. They get a little bit more complicated than the ones I did previously, but when we did derivatives, we also looked at these types of problems, and we'd always, if you remember that, we'd always change these to their powers here. We change them to things like this so that we have their exponents, and we can deal with this with the power rule. So now that we can do this, we can deal with the power rule using integration. So we're going to take and add 1 to the power, which will give me a -1, and divide by that number. Minus x to the add 1 to that power, 1/2, divide by that number. Plus c, don't forget the c. -1 minus 2 x to the 1/2 plus c. Okay, you can leave your answer like that, or you can bring it down as -3 over x. All right, number 9 here. We're going to, now this one's tricky. You're like, well, what's going on with that one? What do I do? It's not part of the rules. Well, look at this. Whenever we have x's like this, and we only have one of the x's, we're going to change these guys to their powers. So this is like x to the 1/2 over x squared plus 1 over x squared. Now we can do that because it's a plus in the numerator. But if this was a plus in the denominator, I could not split them apart like that. So we're going to get the integral of x to the 3/2, -3/2 that is, -3/2, because I'm going to subtract that, plus x to the -2 dx. Okay, we want to put the dx there. That's called our differential. We want to put that there in our integral, telling me what variable to integrate. Use the power rule here, so I'm going to x to the -1/2 divided by -1/2 plus x to the -1 divided by -1 plus c, which is going to give me -2 x to the -1/2 minus x to the -1 plus c. Let's look at one that has a trig function. So the integral of 2 cosine theta minus 3 sine theta d theta. So here we go. The antiderivative of cosine is sine. So we're going to have 2 sine theta minus, well, actually it's going to end up being plus, because the antiderivative of sine is negative cosine. So we're going to have that negative times that subtraction there, that negative times negative, which is going to make that positive, plus c. Don't forget the plus c. Okay, next one here. Cosine x over sine squared x. Now, we don't have a rule for that, right? So we got to get it to look something like this. So I'm going to take a trip back. Take a trip back to pre-calculus, and we're going to have the cosine x over sine x times 1 over sine x. So basically, I split up sine x. I split up sine squared to 2 of these here. Put one of them under the cosine. This right here, 1 over sine x. 1 over sine x is cosecant x. And cosine over sine is cotangent. And we end up with this one right here. So we get negative cosecant x plus c. That's our answer. All right, so let's take a look at, sometimes, we have what we call an initial condition. This is like our starting point right here. And our starting point gives us an opportunity to solve for c. All right, so let's take a look. We got f prime of x equals x to the -3rd. So I'm going to take the antiderivative of that. I'm going to take the antiderivative with respect to x. So x -3 dx, and we're going to get f of x to be negative x to the -2 over 2, right? Because I did divided by the negative 2 plus c. All right, so this function right here, this function that has a c in it, this is a family of curves. This is called a family of curves. It's the curve family. It's the x to the negative 2 over 2, negative x to the negative 2 over, it's all on negatives. It's a negative family here. I don't know if I'd be part of this family because it's a negative family of curves. Negative x to the negative 2 over 2 plus c. It's a family of curves. There's a lot of different curves that can possibly be here. We're going to find one of those curves by plugging in 1 and finding what that c value is. All right, so we're going to find f of 1. We're going to plug 1 in. And we know that f of 1 is equal to 3 halves. So we're going to use that to solve for c. We solve for c and we get c equals 2. So we're going to get f of x equals negative 1 over 2x squared. I just changed that to the denominator here. Plus 2. This is where my c went. Now this one is a specific, this is a specific curve. This is one curve. One curve in the family of curves. This is like my cousin curve. All right, this is like my cousin curve. You know, this is cousin curve 2. I got tons of cousins in my family of curves. I got cousin 3 and 3.5 and all these cousins, all in this family of curves, because c can be something different. All right. So there are a few more examples of using integral rules for antiderivatives. All right. All right. We'll see you soon in another video. I got one more video, few more examples. Bye.